Namaste, I am Dr. Kiran Yadav. Welcome to the digital session of Jayoti Vidyapeeth Women's University. This session is for DET and DET+B.Tech third trimester. The topic that will be covered today is electric field due to electric dipole. Okay, whenever an electric dipole is present somewhere, it creates an electric field in its neighborhood because electric dipole has charge, and charge always creates electric field in its neighborhood. So electric dipole will also create an electric field. We will calculate the value of this electric field which is created due to an electric dipole. So as the electric field is created due to electric dipole, we also called it as dipole field. Okay, so the electric field due to electric dipole is also known as dipole field. Okay, so for calculating the value of electric field, first we take a point in the neighborhood of the electric dipole. At this particular point we need to calculate the value of electric field. Okay, so this point that we take can be on the axial line or equatorial line of the electric dipole. So depending on where this point is, and this topic is further divided into two types. In first case we will find the electric field due to an electric dipole on an axial line. Okay, then we will find the electric field at a point on equatorial line. Okay, I will later explain you the meaning of axial line and equatorial line. So first I will discuss about electric field at a point on the axial line of electric dipole. So here we have an electric dipole. At point A the charge is minus q, and at point B the charge is plus q. The distance between these charges is 2a. Okay, and the dipole moment is represented by P, and this direction is from negative charge to positive charge. Now we need to find electric field at a point P. This point in axial is on the axial line of an electric dipole. Okay, so this is the line that joins both the charges of the dipole. So if I extend this line to the right, then it can be drawn like this. Okay, so and if I extend this line to the left, then it can be drawn like this. So any point on this line will be a point on axial line. This whole line from here to here is termed as axial line. Okay, so if we need to calculate the electric field at any point on this line, then this is the process that I will be discussing. Okay, so we take a point P which is on the axial line of the electric dipole. This point P is at a distance r from the center of the electric dipole. Okay, so the distance from A to B is 2a, and the distance from O to P is r. Clear? So now there are two charges in the electric dipole, minus q and plus q. So there will be two electric field at point P. The first electric field E1 will be due to charge minus q at A, and the second electric field E2 will be due to the charge plus q at point B. So we will calculate both the values of E1 and E2, and to find the resultant electric field at P, we will add both the values. Okay, is that clear? Now electric field at point P due to charge plus q. Okay, so we will find electric field at P due to this charge. Okay, so we know the formula for electric field is kq upon r square and r cap, where r cap is the direction and k is the constant, 1 upon 4 pi epsilon 0, kq upon r. Here r is the distance. So here we are calculating the electric field at P due to this charge. So we will have to see this distance BP. Okay, so we can see that this distance from P to O is r, and the distance from O to B is a. So the distance B to P will be equal to r minus a. Okay, so in the formula for electric field we write q upon r minus a square. In place of r we have written r minus a. Okay, here P cap is the direction. The direction will be like this. Okay, direction will be in this direction, E2. Oh, sorry, this is due to positive charge, so the direction will be this direction, E1. Okay, we know the direction of electric field for a positive charge is outwards, so direction will be in this direction. Now we calculate E2, the electric field at point P due to charge minus Q. Okay. Again we need to calculate the distance AP. So the distance from P to O is R and from O to A is A. So the total distance AP will be R plus A. So in place of R, for the formula of electric field, we write R plus A. So this becomes the magnitude of electric field due to negative charge. Okay. So now for a negative charge, the direction of electric field is toward charge. So due to negative charge, the direction of electric field will be in this direction. E2 will be in this direction. So if this direction is P cap, then this direction will be denoted by minus P cap. So that's why we denoted E2 by minus P cap. So the resultant electric field at point P will be the sum of both the electric fields. So we add both the electric fields, E1 and E2. On adding these, we get this relation. Okay, we take these quantities as common and we are left with these two terms in the bracket. By taking LCM on further solving, we get this equation. Okay, here the denominator is R minus A is to square, here it is R plus A is to square. So when we take LCM, we will multiply both R minus A square multiplied by R plus A square, and then we use the identity A square minus B square is equals to A minus B, A plus B. By using that identity, we can write the denominator like R square minus A square is to whole square. Okay, so we get this. On further solving these square, okay, these two terms, these square terms, we use the formula A plus B square is equals to A square plus B square plus 2AB, and for A minus B whole square is equals to A square plus B square minus 2AB. We expand these terms using these two formulas, and then there are some terms which get cancelled out, so we are left with only one term, which is 4AR. Okay, so try to solve this by your own, and if you have any doubt in getting this term, then you can mention in the comment section. We get this. Okay, so the direction here is P cap, and here we can write this Q and 2A as P. So we write 2AQ as P. So we are left with 2PR. Okay, so this is the final formula that we get for the electric field due to an electric dipole at a point on the axial line of the dipole. Okay, so I hope this is clear to you. Now another approximation that we consider, if A is much less than R, value of A is very small, then this A square term can be neglected as compared to this R square term, because if A is very small, its square will be even more smaller, and R is very large, so its square will be even larger. So this term can be neglected here. In that case, this denominator term, this term will be written as R square is to power square, which is equal to R is to power 4. Then we can cancel one R from the numerator and one R from the denominator. So we will be left with this term 2P upon R cube. Okay. So these are the formula for E axial in case when the value of A is much smaller than R. Okay, so it is clear that the value of electric field due to an electric dipole at a point on the axial line is inversely proportional to R cube. E is inversely proportional to R cube. So this was in this session. If you have any doubts, please mention in the comment section. Thank you.